Alright everybody, in this video dealing with rotational inertia, we are going to talk about how all these objects start to roll. Inertia is your resistance to a change in motion. So rotational inertia is the same resistance to a change in your rotational motion. So it's how fast or how slow you're going to start rotating. All of these equations that we have over here on the left are for common items, and it gives the equation for their moment of inertia, their rotational inertia. The hoop over here has the greatest rotational inertia. So when your rotational inertia is high, that means that it is hard for you to start rolling. And as you can see, we have all things about rod about the center, a rod about the end, and what you're really looking at here are these fractional values out in front of the mass and the radius or the length squared, whichever it is for them. So all of these have pretty much the same formula. It's just this value out in front here which determines if you have more rotational inertia or less rotational inertia. The main three that we're going to be dealing with are hoop, solid cylinder, and solid sphere. We might come back to rod about the end once or twice, but those are the three main ones that we're going to deal with in this unit. Alright, so let's see if we can solve an equation. What is the rotational inertia of a hoop with a mass of 3 kilograms and a radius of 2 meters? So here is my hoop. It's just all the masses on the outside. So as your average distribution of mass is further away from the axis of rotation, the more inertia you're going to have. So all my mass is located all out here, so I have the greatest rotational inertia. So for a hoop, I is equal to mr squared. So my mass is 3 kilograms, my radius is 2 meters, that whole guy gets squared. 2 squared becomes 4. 4 times 3, my rotational inertia here is 12 kilogram meter squared. Those are just the units. They don't have anything cool like newtons, but that is the rotational inertia for my very large hoop. Now, what's the rotational inertia for a solid sphere that has a mass of 5 kilograms? So here's my solid sphere. It's got a mass of 5 kilograms and a radius of 4 meters. Of course it does. So I is equal to 2/5 mr squared in this situation. So here my mass is 5 kilograms, 2/5 comes out front, 4 meters gets squared, so 4 times 4 is 16. The 5's cancel out. 16 times 2 gives me a rotational inertia of 32 kilogram meter squared. So as long as you're dealing with simple numbers, it can be a simple solution to solve for the rotational inertia of any object.